This is the first of 3 videos I will make to go over all of the solutions to the Unit 1 review. Starting with 1a, here we have square roots and we have negatives underneath. So what we could do first is just simplify this radical. So this will turn into a 9i, because it's nice because these two numbers are perfect squares, and then we'll have times 7i. Multiplying this together, we'll get 63i squared. And if you recall, I squared is equal to -1, so this is the same as saying 63 times -1, or -63 is our final answer. For b, we can go ahead and start by taking out the square root of -1, so that becomes an I. And then for 250, we want to factor that into 25 times 10. 25 is the largest perfect square that goes into this. So that will come out as a 5, so we'll have 5i radical 10. Now for C, unlike A, we are going to take the i's out here, but I can't take the square root of 8 or 6. They're not perfect squares. What I am going to do, though, is write I radical 8 times I radical 6, and then we can multiply the i's together to get I squared. And then I could put these back under, multiply them together. It's just one number to try to refactor this using a perfect square. So I squared again is -1. And then the largest perfect square factor of 48 will become 16 and then times 3. So we'll take the square root of 16, so that becomes -1 times 4 radical 3. So then we get -4 radical 3. All right, for problem 2, these are all powers of I. So what we want to do here is factor, and the first exponent we need, 4 needs to go into it. So the closest number to 82 that 4 goes into is 80. And then we multiply by I squared. So when we multiply powers like this, we add the exponents. So I to the 80th, that's going to become a 1 because 4 goes into that. And then I squared is a -1. So 1 times -1 is -1. With B, I to the 24th, well, 4 goes into 24. So there's nothing we need to do. That's just a 1. Because again, if you recall, we just start off with I equals I squared equals -1, I cubed equals -I, and I to the 4th equals 1. So if we counted 24 times, this being 1, 2, 3, 4, 5, 6, 7, 8, and we kept going up to I to the 24th, we counted 24 times, we would end up right back here. All right, for C, I to the 33rd, we're going to say I to the 32nd, and we just need one more I left over. So again, I to the 32nd is 1 times I, so it's just I. And then I to the 63rd, well, 4 can go into 60, so we're going to have I to the 60th times I cubed. So I to the 60th becomes a 1. I cubed is -I, and then that just stays as -I. All right, for 3a, we are just combining like terms. So I can just rewrite this as 2 minus 3/5 I. Nothing changes there. However, I need to subtract the next two terms, and then I get -5 minus 2/3 I. So because these are two complex numbers, I want to go ahead and combine the real terms. So that's 2 minus a 5. So I want to do 2 minus a 5. So that's going to give us a -3. Then I want to combine the fractions here. So we're going to need to, I'm going to write this out off to the side over here. So we have -3/5. Now they're both negative. So I really want to combine. We'll do -3/5. I'll ignore the I right now and then just put it in at the end. -3/5 minus 2/3. So I need common denominators of 15. So 5 times 3 is 15. So 3 times 3 will give us 9. 3 times 5 is 15. So 2 times 5 will give us 10. So these two together will turn into -19/15. So we'll have -3 and then minus 19/15 I. For B, we're using the distributive property or the FOIL method. So we first want to multiply 4 times 3, which is 12. 4 times a -2i is -8i. Inside terms, we'll get a -18i. And then last, we'll get a positive 12i squared. So I'm still going to have a 12. I can combine my two middle terms here. That'll give me a -26i. And then I squared will turn this positive 12 into a -12. Well, the 12s actually cancel, so I really have a 0 minus 26i. We don't need to write the 0. It's just negative 26i. For C, we've seen this one quite a few times. We don't want to leave the I in our denominator, so all we have to do in this case is multiply top and bottom by I. So now this will give us a 3i over an 11i squared. 3i just stays at the top, but now I squared will turn 11 into a negative, so we just write it as negative 3/11 I, or negative 3i over 11. And then we've also seen a problem like D quite often. We have binomials here, so definitely put them in parentheses. We need to multiply by the conjugate of the denominator, so that's going to become a 2 minus 7i. So now again, carefully multiplying across the top, we're going to get a 10 minus a 35i. Inside, we'll get a minus 8i. And then last, we'll get a plus 28i squared. In our denominator, I still need my first terms here. That's going to be a 4. My outside and my inside will cancel. We'll get a minus 14i plus 14i. They cancel. So last, I'm going to have a minus 49i squared. So now in the numerator, I can combine 10, and this is really a minus 28. So 10 minus 28 is a negative 18. Negative 35i with a minus 8i is going to be a negative 43i. And then in my denominator, this really becomes 4 plus 49, which is 53. But to truly write this in the a plus bi form, we just separate the fractions. So negative 18/53 minus 43/53 I. Okay, for number 4, we're just after the discriminant. That's the part of the quadratic formula that's just underneath the square root. So it's b squared minus 4ac. So in order to see all the values of a, b, and c, we need to get every term on one side in this order set equal to 0. So the value of the discriminant, I'll just abbreviate here. So b is negative 4, so we'll have negative 4 squared minus 4 times a, which is 2, times c, which is 7. So this gives us 16, and this is 8 times 7, so we get 56, so we get a negative 40. So when our discriminant is less than 0, we have no real solutions, or just no solutions. Because what this means is we're going to end up taking the square root of a negative number, so we actually have 2 complex solutions, but we're just trying to say 2 non-real solutions. All right, for b, because this 10x is over here, I need to bring this over to the other side. So we'll get x squared, and then this will become plus a 15x. So then the discriminant is going to become b squared, so we'll have 15 squared minus 4 times a, which is 1, and in this case c is 0. So we just end up with 15 squared, which is 225. And because that's greater than 0, we'll have 2 real solutions. Now for c, we have to do a little bit of work before we move everything over to one side. So I want to distribute the 3x into here, so we'll get 3x squared plus 12x equals 2x minus 2. Bring everything over to one side. So we'll get a plus 10x, and then plus 2 equals 0. So the discriminant here is going to be b squared, so we'll have 10 squared minus 4 times 3 times 2. So we get 100. And then that's minus, we'll have 12 times 2, so we get 24, which is 76. Kind of like part B, it's greater than 0, so we have 2 real solutions. Now, if the discriminant ever turned out to be 0, we would just have 1 real solution. So make sure you keep that in mind. All right, and then 5, we have several types of equations that we're going to solve for. That's why I just wanted to get through this part in the first video. So for 5a, this is where we need to factor this first denominator. And actually factors, what's going to help us is the other 2 denominators here. So this actually factors into a 2x and an x. and we would do a 5 and a 3 because this will give us 6, so this will give us 5, and if we did a plus 3 and a minus 5, so if you notice those are the other two factors. So this is my LCD. This is what I want to multiply everything by. So I'm going to go ahead and write that next to each part. Put that over 1 times our first fraction. Now when I go to write this denominator right here, I'm going to write it in factored form. It'll just be easier to see what's going to cross out. All right, so because this denominator has both of them, they just cross out, and over here I'm left with negative 11. Over here, this 2x minus 5 will cross out with this one. I'll write the 2 first. I'm left with 2 times the quantity x plus 3. And then over here, the x plus 3's cross out, so I am left with, that should only be a minus sign there, 2x minus 5. All right, and then we'll distribute here. So we get negative 11 minus 2x minus 6 equals 2x minus 5. I'll combine the negative 11 with the negative 6, so we get a negative 17 minus 2x equals 2x minus 5. I'm going to go ahead and add 2x to each side, so that's going to leave me with a negative 17 equals 4x minus 5. And if I add 5, I'll get a negative 12 equals 4x. Divide by 4, so x would equal negative 3. But we have to check this. So if we go back up to our denominators right here, and technically here too, because it has both of them. With this denominator being x plus 3, x cannot equal a negative 3. If I were to set 2x minus 5 equal to 0 and solve for x, I get 2x equals 5. X would equal 5 halves. So this would tell me that x cannot equal a 5 halves. But because I did get an answer of negative 3, we can't keep it. So this does not satisfy the equation. We would have no solution. So you could write that or the empty set, or just the words no solution. All right, for B, it's actually set up kind of nice here. We don't actually have to expand this. You could, but you're causing yourself more work. What we could do is just add 2 to both sides. So we get the quantity 3x minus 4 squared equals 13. So this is like part of completing the square process has already been done for us. And now I want to take the square root of both sides. So we'll get 3x minus 4 is going to equal plus or minus the square root of 13. We need the plus or minus because, again, I'm taking the square root of both sides. And then we'll just add 4. So we'll get 3x is going to equal 4 plus or minus radical 13. And then last, just divide by 3. And we could leave it all as one big fraction. 4 plus or minus radical 13 over 3. Now for C, this won't factor. If you brought the 4 over and set it equal to 0, it won't factor. You could use a quadratic formula, but I'm actually going to use completing the square. So what I want to do is leave everything where it is. But I have to figure out what I want to add to each side. So here I'm going to take half of the 10, which is 5, and square it. So that's 25, and I have to add it to the other side. Now I can factor this as the quantity y plus 5 squared, and this will give me 29. Now just like, this is kind of like the step that we were just given here. So I want to go ahead and take the square root of both sides. But over here I need plus or minus the square root of 29. So we get y plus 5 equals plus or minus radical 29, and just subtract 5. So y equals negative 5 plus or minus radical 29. All right, now in part D, or problem D, we're going to have to start by distributing the 6t. So this will first give us 12t squared plus 6t equals 5 minus 5t. Now, I'm not sure if this factors or not, so I'm going to bring everything over to one side. So with 12t squared, if we add 5t, we'll get plus 11t minus 5 equals 0. I'm going to go ahead and try this. And here's a nice way to tell. If I multiply 12 times 5, that would give me 60. And I need factors of 60 to help me get to 11. And factors of 60 could be 2 and 30. Well, that won't get me to 11. 3 and 20, that won't get me to 11. 10 and 6, that won't get me to 11. Something that's hidden, well, we know 12 and 5, but that won't get me to 11. 15 and 4, and we have 60 and 1. So 15 and 4 is what I'm actually after. So I'm going to factor this. So we'll try 4t and 3t. So I need to get a 15, so I'm going to put a 5 here and then a 1 here. So this will give me a 4 and a 15. That'll get me to an 11. My signs have to be different to get a -5 here, and I also need to subtract. So if I put the negative here and the plus here, this will give me a -4t plus 15t is 11t. So then I'll set each of these equal to 0. So we'll get 4t is going to equal -5, so t is going to equal -5/4. And then over here, 3t equals 1, so t equals 1/3. All right, for E we have, it is quadratic, but we also have fractions. So I'm going to go ahead and multiply everything up here by 4. So when I distribute here, that's just going to leave me with a 3x squared minus a 4x, and then this will leave us with a -2. I'll bring the -2 over. Now here's how we could check if this will factor. If I multiply 3 times 2, that's 6. There are no factors of 6 that will help me get to 4. So I'm going to use a quadratic formula here. So x is going to equal the opposite of b, so that's going to be a +4 plus or minus square root. B squared will always turn into a positive number here, 16, minus 4 times a times c, all over 2a, so 2 times 3 will give us 6. So here we get 4 plus or minus, we'll get 16, and then this will give us 24. So we're going to have a negative number underneath our square root. So we get x is equal to 4 plus or minus, we'll get a -8 underneath the radical over 6. We need to simplify this, so this is going to become 4 plus or minus, and I is going to come out, and radical 8 becomes 4 times 2. So we're going to have that 4 also come out. So we're going to get a 2i radical 2 over 6. Now with the 4, the 2, and the 6, I could simplify this. I can divide everything up here by 2. So we're going to get 2 plus or minus I radical 2 over 3. All right, for F, notice we have 4 terms. I actually want to factor by grouping here. I want to get everything over to one side. So I'll move everything over to the left. So we have 12y cubed plus 24y squared minus 3y minus 6 equals 0. So I'm going to group my first 2 terms together and then my next 2. I'm going to factor out a GCF here, which is going to be 12y squared. That's going to leave me with a y plus 2. Next, I'm going to factor out a minus and a 3. So a -3 I could factor out. We should be left with the y plus 2 for this to work. So a -3y minus 6. So then I make 2 sets of parentheses. What's going to go in the first one is going to be the common binomial factor of y plus 2. And what goes in the other one is a 12y squared minus 3. Now I'm going to set both of these equal to 0. So right here, y is going to equal -2. Over here, I'll just isolate the y by using inverse operations. So I'll get 12y squared equals 3. Divide both sides by 12. I'll get a 1/4, 3/12. I still want to take the square root here. So we'll get y is going to equal, I need plus or minus square root of 1 over square root of 4. And this simplifies nicely to plus or minus 1/2. We have 3 answers, -2, +1/2, and -1/2. All right, now G, there was a little bit going on here. Now, no matter which way we start this, it's going to be quite a bit of work. So what I'm actually going to do is rearrange some terms here. I'm going to move the -d, radical d plus 7 over to this side and make it positive. I'm going to leave the 1 here, and then I'm going to move the radical 2d over here. Just because this is, it still has some things going on underneath the radical, but it's the simpler of the two. So now I want to square both sides. But remember, this squared right here becomes 1 minus radical 2d times 1 minus radical 2d. So over here, I'm going to get d plus 7. Let's go through and distribute this. We're going to get a 1 minus a radical 2d, another minus a radical 2d, and then a negative times a negative will get a positive, and radical 2d times itself just gives us 2d. So now we have 1 minus 2 radical 2d plus 2d. So now what I could do, I'm trying to isolate this radical right here. So I'm going to subtract 2d from both sides. So this will give me a negative d, and then I'll subtract 1. So we're going to minus 6. I'm sorry, positive 6. And then that's going to equal a negative 2 radical 2d. So let's write this as 6 minus d equals negative 2 radical 2d. Then I want to divide everything up here by negative 2. So now we're going to get a negative 3 plus d over 2 is going to equal radical 2d. Then I'm actually going to switch this around again. D over 2 minus 3 equals radical 2d. Now I'm at the point where I need to square both sides again. So now I'm going to square d over 2 minus 3 and write it like this. So when I go to multiply here, I'm going to get d squared over 4 minus 3d over 2 minus another 3d over 2 and then plus 9. So here I'm going to have d squared over 4. This will give me a minus 6d over 2. Minus 6d over 2 turns just into a negative 3d. So we'll have minus 3d plus 9. So we'll have d squared over 4 minus 3d plus 9. And then this will just turn into a 2d. We're almost done. How about we go through and we multiply everything by 4? So now this gives me d squared minus 12d plus 36 equals 8d. Let's bring everything to one side. So I want to subtract 8d here. So we get d squared minus 20d plus 36 equals 0. This should factor quite nicely. We'll have d and d. 18 and 2. Our signs are the same and they're both minus. So d is going to equal 18 or d is going to equal 2. But it's still important to check. So if I go back up to the original equation, square root of 2d equals 1 minus radical d plus 7. So when d is 18, I'm going to get the square root of 36, 2 times 18 equals 1 minus 18 plus 7 is 25. So I'm going to get 6 equals 1 minus 5. Well, that's not true, so I can't keep that one. When d is 2, we're going to get the square root of 4, 2d, equals 1 minus the square root of 2 plus 7 is 9. So this is 2 equals 1 minus 3, and that's not true. So we did all of this work, and it turned out that neither solution satisfied the equation. But we didn't know until we did find those two solutions. Okay, looking at equation H. I want to first start by adding 11, so we get w to the 4/5 equals 11. Then I need to raise both sides to the reciprocal here, so 5/4 equals 11 to the 5/4. Because our denominator here, our bottom number is even, we need the plus or minus. So we're going to w equals plus or minus, and we'll just say 11 to the 5/4 because we can't take a 4th root of 11, so that's just how we're going to leave it. All right, now something like I, this is of quadratic form. We don't have to leave it this way. And when we do use a different, or set this equal to something, we want it to be equal to something different. Don't use the variable that's here. So I'm just going to let, in this case, since I have k's here, I'm going to let x equal 5 minus 2 over k. So now the equation becomes x squared minus 6x minus 27 equals 0. Now I can try to factor this. We'll have x and x. 9 and 3 should work here. I need a negative 6, so minus 9 and a positive 3. So then x is going to equal a 9. X is going to equal a negative 3. So now I bring this back in. So 5 minus 2 over k equals 9. 5 minus 2 over k equals negative 3. What I'm first going to do is just subtract 5. So negative 2 over k is going to equal 4. We're going to multiply both sides by k, so we get negative 2 equals 4k. Then divide by 4 carefully. K equals negative 1/2. Over here, same thing. Let's subtract 5, so we get negative 2 over k equals negative 8. Multiply both sides by k, so negative 2 equals negative 8k. Divide both sides by negative 8, so k is going to equal a positive 1/4. All right, and two more. These are absolute value equations. So in this first one, I want to go ahead and add 6 to both sides. So now this will give me a 4. And we're used to seeing this the other way, so we could just flip this around. Absolute value of x minus 3 equals 4. That's not a special case, so we separate this. X minus 3 equals negative 4, or x minus 3 equals 4. Add 3, so we'll get x equals negative 1, or x equals 7. And those do both satisfy the equation. Now for k, we're going to set 2x plus 5 equal to 2x minus 1, or 2x plus 5 equals the opposite of 2x minus 1. So we get a negative 2x plus 1. So we'll solve here. This will actually give us, the 2x's will cancel. This gives us a false statement, so we would get no solution helping us here. Over here, I'm going to add 2x to each side, so we get 4x plus 5 equals 1. 4x would equal a negative 4. X would equal a negative 1. So we don't get any answer for the first part that we rewrote, but x equals negative 1 would also be the only solution of the two.